Hello everyone, in this video we're going to talk about another example involving a complex fraction. Okay, so suppose that we have something like this. A divided by B plus B divided by A divided by this sum A squared over B squared minus B squared over A squared. So the best thing to do here is to realize that you want to you want to use the uh, least common multiple of b squared and b. Okay, uh, precisely. Well, let's see. So the LCD for the first fraction on the top would be AB, right? If you want to combine these two denominators, so it would be AB. But the LCD for the bottom two fractions, the a squared and b squared, will be the product of that, right? A squared and b squared. So you want to use this LCD as a k constant. Okay, so you want to multiply this huge fraction, the parent fraction, by a squared over a squared b squared divided by a squared b squared. And why? Because this will make sure that these small denominators in the parent denominator will be gone, right? And it will also reduce this b. Of course, if you're getting rid of b squared and a squared here, the a's and b's will also be gone. You see, this is the reason why we choose this LCD instead of AB on the top, because AB will make sure that these a's and b's are gone, but b squared and a squared will simply be reduced as a result. So we have to use the least common multiple of b squared and a and b, which is going to be b squared a squared product. Okay, so when you multiply this parent fraction by a squared b squared over a squared b squared, you will get I'm going to work step by step to show you what's going to happen. So a over b will be multiplied by a squared b squared. I'm going to distribute that, in other words, plus b over a times a squared b squared divided by a squared over b squared, a squared b squared. Again, we're going to distribute that as well to each of these fractions, subfractions, then minus b squared over a squared, and again multiplied by a squared b squared. So what's going to happen after that? Well, after that, let's see what happens. The b squared divided by b will give you a b on the top, and the a squared will multiply the a to give you a to the third. Okay, but so you will remove this fraction. In other words, you're going to have a to the third b. Okay, because the b goes away and the b squared is reduced to b on the top. So a to the third b plus, now what's going to happen here? A will be gone, a squared will turn to a in the numerator, and then the b squared turns to b to the third because it multiplies the b, so we're going to have a b to the third. Okay, and once again we got rid of these small subfractions in the numerator of the parent fraction given in the beginning. So now the denominator will follow the same trend, right? It will be the b squared will go away, right? Because there's a b squared on the top and the b squared in the denominator, so they turn to 1. A squared multiplied by a squared is a to the fourth, and then minus, and then a squared will go away in this case, and the b squared will multiply the b squared to give you minus b to the fourth. B to the fourth. Okay? So now as a result, what can we do? Is there any way we can simplify? Well, let's try to factor the top. As you know, the common factors, the greatest common factors of a to the third b plus a b to the third is actually ab. Okay, so the product AB is the greatest common factor of these two terms on the top. So what should we multiply the AB to in order to have a to the third b? Well, we already have the a, so we have to have only a squared, and then the b is already there, so we don't need to have anything else. And then plus the second term is a b to the third, so a does not need to be written, it's already there. And b to the third, we already have 1b, so it's going to be b squared that we're missing. Okay, now divide that by a to the fourth minus b to the fourth. Now there's still room to go, there's still something left to do. So realize that you can factor a to the fourth minus b to the fourth using the same technique as you can use when you have a difference of two squares. Okay, so when you have a difference of two squares, recall that you will use this property, a plus b times a minus b. Okay, now in this case the power is the fourth. Okay, so the difference of two quadruples, or however you want to call it, you will use it in the same fashion, except you will just have squares for each term. For all a's and all b's, you will have squares. That's the only difference. Okay, but there's a minus sign and a plus sign. There are alternating signs when you want to factor this out. Okay, so let's see. So ab, we copy that as usual, as it was before. A squared plus b squared over, now let's factor that. So we're going to have a squared plus b squared times a squared minus b squared. Okay, so we did the same thing as we normally would for the difference of two squares, except that there's a difference of two quadruples. Okay, so now notice that we have a squared plus b squared as a common factor in the numerator and denominator, so we can actually cross these guys out, and we're left with ab over a squared minus b squared. And even if you can factor this, as is already done there, you can't really do anything on the top with that, right? Because the middle term will be gone anyway. Okay, if you use the FOIL method, in other words, to rewrite this, you will only have two terms, a squared minus b squared. So there's nothing you can further do to this. So this is the simplified form. You just simplified a complex fraction that was originally given to you. Okay, thanks for watching this video, and I'll see you in my next video.